Hello again, AP Calculus students of the future. Mr. Ford here from the home studio. Today we're talking about topic H of our summer packet, solving quadratic and polynomial equations. So this one is another one that, in the last video I was pretty explicit about this being very, very important. This one is also very important. This is one of those ones that I hope is probably more on the review side for you than anything that's seeming kind of newish. But it is going to take advantage of a property that we use all the time in all of high school math and some pretty common things. So I'm going to slide off to the side before we start, and I'm going to review a couple things. Actually, really only one thing. I'm going to remind you about a thing called the zero product property, which is really the only property we're going to take advantage of here. You might notice right away that a lot of these equations are set equal to 0, and if they're not, like in the case of number 4, the first thing we're going to do is subtract the 2 from both sides to make them equal 0. Because here's the thing, when you have 2 or more things that are multiplied together that equals 0, basically if A times B times C equals 0, let's say that. It could be 4 things, it could be 2 things, doesn't matter. If you have things that are multiplied together and they equal 0, then one of these things must be equal to 0. That's the only way. The only way you can multiply numbers together and get 0 is if one of them is 0. And so you have to investigate the possibility that any one of these 3 things could be 0. So let's take a look at an example and I'll show you what I'm talking about. Number 1. Number 1's a pretty straightforward factoring game. X squared plus 7x minus 18 equals 0. I mean, all we're going to do here is factor this, and since the leading coefficient is 1, just something times x squared, this is pretty easy to do. Whenever you have just an x squared in front, I don't recommend using any particular strategy. I think just, go ahead and put an x here and an x here, and you got to play the same game you usually play when you're solving something like a diamond problem, which is what multiplies to negative 18 and adds to 7. In this case, let's see, I think 9 and 2 and a positive 9 and a negative 2 will do the trick. Plus 9 minus 2, like that. There you go. Oh, shoot. See, this happens all the time with this particular tablet. Now I have to stall while I get it recast. Hopefully it won't happen again. We'll see, though. We'll see. Now that I've started recording, I don't want to do this too many times, but you can go ahead and skip. Whenever you see that happen, you can go ahead and skip ahead about 30 seconds. You'll be right back to where we were, which is right here. Okay, now what we're going to do now is take advantage of the zero product property because we have x plus 9 times x minus 2 equals 0. And this is only true if one of them is 0. So this means that x plus 9 equals 0 or x minus 2 equals 0. One of them has to be 0. And this really for you means that x is negative 9 or x is 2. That's that. We've already talked about this property a couple times, or actually used it in other problems earlier on in this series, so you probably are already aware of this, but it's worth mentioning in detail just this once. So that's the strategy we're going to use on all the problems on this page. We are going to factor them, set them equal to 0, and figure out what x must be. We're going to have a lot of common things that are going to pop up along the way. So let's start with number 2. Now this problem you can handle a couple different ways. You might already recognize the pattern happening here, but if you don't, I wouldn't blame you. I didn't see it until I looked at the answer ahead of time. But I think whenever you have a fraction involved in these problems, a really good idea is to get rid of the fraction by multiplying by the denominator. So I'm going to start this problem by multiplying everything in the problem by 4. And that will give us 4x squared plus 4x plus 1 equals 0. And again, you might recognize this from a previous problem that we actually had on another one of these series. You might recognize this is a really common problem that is just kind of thrown out there in the ether. Now, you can factor this by any number of methods. Right now, whenever you have a number that's not 1 in this slot right in front of x squared, there's a number of different methods that work. I think guessing and checking, honestly, is the way that I usually go with. And I know that's not satisfying to hear from your teacher, but that's honestly the one that usually works the fastest for me. 2 numbers that multiply to 4x squared, and also 2 numbers that multiply to 1, and they have to vibe together to make the 4x in the middle. You can guess and check it for a while, but 2x plus 1, and then 2x plus 1. Again, is going to be the thing we want to do there. We'll review some other methods for factoring this, some more like step-by-step versions in the next couple examples, but for now I just wanted to bring this one to your attention. The reason why is you might recognize this is a perfect square trinomial. That's what this is called, because this is 2x plus 1 squared. So this up here is actually a perfect square trinomial, which is the kind of vocabulary that only a math nerd could even ever care about. But I'll just throw it out there for now. It doesn't really matter too much, honestly. So what this means is there actually is only one zero. If you were to graph this, it's going to actually just touch the x-axis and then bounce off it. But we're not talking about that in this video, so I'm going to just move ahead with the answer. So what this means is that 2x plus 1 is 0, and that means that x has to be equal to negative 1/2. That is the only value of x that works for this particular problem. And there's only one answer as opposed to 2 because it's the same thing twice. Let's look at number 3. 2x minus 72 equals 0. What did my thing crap? Oh, I have to scroll down. Okay, I was worried that my thing crapped out on me again. This is, again, one that looks like there's not much to factor here because it doesn't look like a trinomial. It's not. But what you can do is you can factor a 2 out, at least. And now it might look a little more familiar. The nice thing is you can ignore this 2 because you could. I'll show you this one time and then never show it to you again. You can divide both sides by 2, which cancels out the 2, and 0 divided by 2 is still 0. So you can just effectively ignore the 2. X squared minus 36 equals 0. You might recognize this as a difference of squares. Another really common thing that pops up all the time in every math class you're going to have from now on. Whenever you have two things that are squared subtracted, you can easily factor them into x plus 6 and x minus 6 in this case. I'll see, there it happens again. I'm going to finish writing this problem, and then we might just have to deal with this throughout the course of this video here. So, again, you can go ahead and skip. You guys are watching this on YouTube later on after the fact, so you can skip ahead 30 seconds every time that happens, because it takes me about that long to get the thing back up and running. Oh, I got a knock at the door. What's up?
How do you like my Kirby balloon, Steve?
It's pretty cool.
Thanks.
Pretty cool Kirby balloon.
Drill ability.
That's my stepson. It's summertime almost, so he might pop in a couple more times. We'll see. Anyway, here that means the answer is x equals negative 6 and x equals positive 6. So there you go. Of course, you can check those answers really quick by plugging them in to the top equation and confirming they both do work. Both those numbers squared is 36, and 2 times 36 is 72. Let's talk about number 4 for a little bit. Number 4 I mentioned earlier. What you want to do in this problem is start by making it into a standard quadratic by subtracting that 2 over from both sides. Let's start with 12x squared minus 5x minus 2 equals 0. And then from there, this is a really common strategy. Whenever you can set a polynomial equal to 0 and then factor it, you've gotten yourself one step closer to the solution. So always look out for this kind of situation. As far as factoring this, so the method that I just taught my freshmen in Algebra 1 would look something like this. We kind of start with a generic rectangle, and we say, okay, 12x squared is down here, negative 2 is up there. And we know that whatever these things, the diagonals always multiply to the same thing. So we know that we're looking for two things that multiply to negative 24x squared. That is the two outside things multiplied together. They also have to add up to negative 5x there. Oops, negative 5x. So this is the game we play. What multiplies to negative 24 and adds to negative 5? Again, here's where I got to think and guess and check. 2 and 12? No. 3 and 8? 3 and 8. 3 and 8. It's got to be. It's going to be negative 8x and positive 3x. There we go. We'll put those in these boxes, and now it will factor nicely. Again, in your Algebra 2 world, you probably know some more complicated ways to deal with this, but in my experience, every math teacher has a couple ways they like, so we'll walk through my favorite way in just a minute here. Column-wise, these guys both have a 4x involved. Negative 2 and 3x only have 1. They have no common factors. Going left and right, 12x squared and 3x both have a 3 and an x involved. And negative x and negative 2 both have negative 2 as a factor. And so the factored version of this is 3x minus 2 times 4x plus 1 equals 0. So that's how I got from the original problem down to its factored form right there. Or you could just guess and check it until it works. That's a little pro tip from me to you. Of course, this means that the answer is going to be x equals positive 2/3. Again, add the 2, divide the 3. Or x is equal to negative 1/4. Subtract the 1, divide the 4. Those are the two answers we're looking for there, 2/3 and negative 1/4. Let's go to number 5. Again, this might be a little, now that we're getting some big numbers in here, these might get a little tricky, a little harder to guess and check with. This is the method that I was taught when I was in high school. Things were a lot more traditional back then, you know. You should be shown one way, and then you do 40 practice problems, and that's it until you get it drilled. So this is the same thing as what I just did in the last problem, but a little less abstract and more like, here are some things to do. So you start with 20x squared times 15, which in this case, I got to use a calculator because I do not know. 20 times 15. Hang on. Do I need a calculator for this? While I'm calculating, let's see if I can think about what it is in my head. Is it 300? 300. So I'm looking for something that multiplies 300x squared, but adds to negative 56. So I got to think of factors of 300 that are the same sign because that's a positive 300. They have to combine to 56. Oh, 50 and 6. That will do. Negative 50 and negative 6. So what I'm going to do now is I'm going to rewrite this equation, but I'm going to split up the minus 56x into minus 50x minus 6x plus 15 equals 0. Now I'm going to look at the first two terms, which, if I've done this correctly, we should be able to factor something out of those two. Looks like 10x will come out of those. And inside will go 2x minus 5. I think that's correct. And now what I'm looking for is I'm looking to factor something out of these two also that is the same, that will leave behind the same factor of 2x minus 5. And if I factor out minus 3, I will get it. Minus 3 times 2x minus 5. Look at that. Equals 0. And now I can factor a 2x minus 5. Since it's part of both terms, I can factor it out of both terms, 2x minus 5, and group together the 10x and the minus 3. And there you go, I factored it. That's the way that I learned how to do it when I was in Algebra 2 in 2001. So there you go. But less important than the actual factoring is how to write the answer now. So remember, both of these could be potentially equal to 0 because they're being multiplied together and they equal 0. 2x minus 5 would give you positive 5 over 2. 10x minus 3 would give you x equals 3 over 10, like that. It's worth mentioning that we're solving these by factoring, which is fine. You can always use the quadratic formula. That's always an option. It's a little bit bulky, but it always will work. Usually we say if you can factor it, you should. You know, this one is going to be kind of a beast here. Now, I would love to show you the slip and slide method. I've been taught that one a few times, but that one's never really stuck with me. I don't really get it, you know what I mean? I think it involves the same kind of stuff, though. But I'm just going to do my best to try this one. Actually, no, I'm noticing something. 81 is 9x squared. 16 is 4 squared. So I'm already suspicious that this is another perfect square trinomial. I'm going to guess right away that this is 9x plus 4 times 9x plus 4. I'm going to try it. Let's see. You definitely have the 81x squared on the left. You definitely have the 16 on the far side. In the middle, you have two pairs of 36x's, which is 72x. Yeah, plus 36x plus 36x. So it totally works. All right, that's it. Cool. Now, I think this is better written as 9x plus 4 squared. So just like number 2, this is a perfect square trinomial. And that means that there is only one answer, and x is equal to negative 4 over 9. You know, we could go into a lot of detail about your Algebra 2 classes and pre-calc classes. You probably talked about things like maybe multiplicity of zeros, the fact that because it's a squared, it's a quadratic, it's going to have 2 zeros. This one only has 1, but it's repeated twice. It's kind of confusing. Honestly, not super necessary. Cool, the kind of things that are cool to know, but not super necessary. So let's go ahead to number 7. Things are going to start getting a little real down here in this section. So again, we're going to use a really common strategy on this one. I'm really glad this problem is a part of it. This is not much fun to deal with in its current state, but much like what we did with problem number 2, we multiplied everything by 4 to get rid of the fraction. We're going to do the same thing here. Let's multiply everything in this problem by another x. We're allowed to do that. What that will do, most importantly, is going to cancel out the fraction, at least one of the fractions. It will leave us with x squared plus 1 equals 17 over 4 times x. And then next, I think we should multiply everything by 4. I suppose we could have multiplied everything by 4x. That would have done the trick also, but I wanted to break that up into 2 steps. This will give us 4x squared plus 4 equals 17x. So it cancels out all the fractions. Now it's a little more easy to deal with. And while we're here, let's just go ahead and move that 17x to the other side. This would be 4x squared minus 17x plus 4 equals 0. And now we can proceed to factor it as we would normally. I'm just going to rely on the good old guess and check method until I get something that works. So I'm going to stare at it for a minute and think about things. I'm guessing it's 2x and 2x. I'm just going to ink them down. I can always erase if I'm wrong. And then 4 would have to be, well, they have to be negative something because it's a minus and a minus. So, no, it's going to have to be 4x and 1x because it's going to be 16 plus 1. So this is, one of these is 4x, one of these is x, and these are minus 4 and minus 1. I think that'll do it because you'll get, oh no, this one is 4x. Oh, okay, I gotta get the order right. This is minus 1, this is minus 4. Because then you'll have this minus 16x from these two. These two give you minus 16x, and these two give you minus 1x, and that's where the negative 17x comes from. There you go. Again, I wish I had a better way of explaining what's going on in my brain other than just guessing and checking. Anyway, the answer is going to be x equals 1/4 from this first one, or x equals positive 4 from this other one there. That's right, the zeros and the linear factors always work backwards. X minus 4 means there's a 0 at 4, whereas x plus 4 means there's a 0 at negative 4. Let's look at number 8. Number 8 looks gargantuan. Usually when you're dealing with cubic functions in this world, factoring cubics makes things a lot more complicated. Usually what you do is you try to find one root or 0 that you know, and then you try to divide the entire thing by that using polynomial long division, and then factor what's left over. That process honestly sucks, so we're not going to do that here. Fortunately, this is kind of a tricky example, so we have a way to trick our ways out of it. Kind of like what we did up above on one of the other examples. We're just going to factor something out of the first 2 terms and then out of the second 2 terms, and it will leave us with the same factor. Here, watch. X to the third minus 5x squared both have x squared involved, and that will leave us with x minus 5 in the parentheses. And if you factor out a negative 5 out of the next 2, you will have x minus 5 equals 0. There you go, just kind of factoring something out of the terms there. And what you're left with is x squared minus 5, taking those 2 terms, putting them together in one group. We're basically factoring out the x minus 5 term. And there you go. That's honestly as far as we can take it. X squared minus 5 is not a difference of squares, so we cannot factor it into its x plus 5, x minus 5 thing. Can't do that because 5 is not a perfect square. So as far as the answers go, since it's a third power polynomial, we should have 3 answers, and we will have 3 answers. For this one, x equals 5. That's the easy one. As far as solving x squared minus 5 equals 0, remember there are going to be 2 answers to this, because if you add the 5 over, you get x squared equals 5. And then when you take the square root of both sides, what you have to remember is that square root has kind of this weird catch to it, where you have to put a plus and minus at the end of the answer. X is equal to plus or minus the square root of 5. And the reason why is because both of those numbers, when you square them, they become positive. So positive and negative square root of 5, when they get squared, become positive 5. And 5 minus 5 is 0. So those are your 3 answers. Your answers are 5, the square root of 5, and the negative square root of 5. If you were to graph this original function up there, that's where you would see this thing cross the x-axis. And as if that wasn't fun enough, number 9 is a 4th degree polynomial, so it's going to have 4 solutions. This one is another really common strategy we use quite a bit. That's actually a lot easier than it looks because all of these terms have at least x squared, so we're going to factor x squared out right away. So that'll leave us with 2x squared minus 15x plus 18 equals 0 right there. And so right away we have x equals 0 as one of our answers, And I said there's going to be 4 answers. This is kind of dumb, and I have never liked this very much or explaining it very much, but this does have 4 zeros, but 2 of them are both at 0. So it's multiplicity 2. Nobody cares. You guys might care. I don't know. 2x squared minus 15x minus 18. Well, 2x is got to be 2x times x. So how do we break up this 18 in this case to get negative 15? It's got to be minus something and minus something, because it's negative 15. How about, I think 3 and 6 will work. Because if I multiply the 6 times 2, it's 12, plus 3 more is 15. So this is minus 3, and this is minus 6. Yeah. So now when you do negative 6 times 2x, you'll get 12. And when you do negative 3 times positive x, you get 3, and 12 plus 3 is 15. There it is. So the other answers are x equals 3 over 2 and x equals 6. There you go. So there's 4 solutions. 6, 3 over 2, 0, and 0. All right, let's take a look at the last question, which looks complicated. But this is, again, what you'll find out pretty quick in calculus is that the calculus test is basically 75% reading. And reading carefully and determining what the solution is, which is pretty true to what most mathematics and physics and math and science puzzles are like these days for regular people who solve math problems for a living, engineers and such. So we have to understand what's being asked of us. We have y equals x squared plus kx minus k. K is just some constant, and it's worth mentioning that it's repeated. It's got to be the coefficient of x there, and then also the constant at the end being subtracted. For which values of k will the quadratic have 2 real solutions? Now, this one we're going to be unable to factor because we just don't have any knowledge about what the numbers are, so we're going to have to resort to a different tool. One we haven't talked about yet. Well, actually, we have mentioned it, but we haven't talked about it. Let's go ahead and use the quadratic formula. Let's pretend for a minute. It's been a while for maybe in the quadratic formula. Negative b plus and minus the square root of b squared minus 4 times a times c all over 2a. This is how you find the zeros of a quadratic equation that's in the form of ax squared plus bx plus c equals 0. So in this case, a is the number 1, b is k, and c is negative k. I think that's important to point out. So let's go ahead and plug those numbers in. We're going to try to solve this, or at least figure out when there's going to be 2 real solutions. It's going to come down to what the discriminant is going to tell us, and that's a very Algebra 2 lesson that you kind of learn and then never think about it again. But the discriminant tells you what kind of solutions you're looking for. If you get a negative number in there, there are no solutions. It's imaginary. If you get 0 in there, there's only going to be 1 solution. And if you get a positive number, there will be 2 solutions. So we are looking for when that discriminant is going to be positive. But let's go ahead and plug our knowledge in right now. So we are looking for negative k plus and minus the square root of k squared minus 4 times a, which is 1, and c, which is negative k. That's all over 2 times 1. So if we clean this up, we got negative k plus and minus the square root of k squared plus 4k all over 2. Now, what we want to do here is think about that discriminant. We want to determine where it's going to be positive, really, is what we're looking for. So we should maybe take that discriminant off to the side and maybe think about it on its own terms. When is this thing going to be positive? So let's solve this problem. Let's grab k squared plus 4k. Let's think about when that's going to be greater than or equal to 0. This might be tough to solve, but it might be easier. Let's think about this. It might be easier if we set it equal to 0 and then determine where it's positive and where it's negative. That might be an easier thing to do, because greater than or equal is going to be a little tricky there. So let's think about this. When is k squared plus 4 squared, where's my eraser, equals to 0? And we can solve this really easily. Remember, k is not a variable. It's actually a constant, so it's just some number we don't know yet. We'll factor out a k, and we're going to get 2 solutions for this. This happens when k is equal to 0 or when k is equal to negative 4. That's kind of our solution. What we're going to do here to determine when this actually happens, we're going to use a tool called a sign chart, which is a really common practice that you'll learn later in this class, but it's good to see it right now. So what we're going to do is we're going to make a number line. and we're going to put negative 4 over here. We're going to put 0 there. And what we're going to do is we're just going to think about an example number that's in all three of these ranges. We got numbers that are less than 4, numbers between negative 4 and 0, and we got numbers greater than 0. We're going to think of a sample number in each one of those categories, and we're going to just kind of plug it into, probably the factored version would be easier, and we'll determine if it's positive or negative. Let's try negative 5, for example, over there. This would give us negative 5 times negative 1, which is a positive number. Doesn't actually matter if what the answer is, just matters if it's negative or positive. If we were to plug in, let's say, negative 1 as a tester in between 0 and negative 4, we would have negative k times positive 3, which would be negative. And if we plug in a tester number greater than 0, like say 1, we would just have 1 times 5, which is positive. So it would appear that we have kind of an answer here. We have numbers that are less than negative 4 and numbers that are greater than 0. That would be the answer we're looking for. Those are the places where this is going to have two solutions. So we'll express our answer in interval notation, which we practiced in a previous video. So let's see, x squared plus kx minus k has two solutions when k is on the interval, let's say round parenthesis, negative infinity, comma, negative 4, round parenthesis. We don't want to include negative 4 here because that's not included. Negative 4 is where it equals 0. We're going to union this together with a set of numbers from 0, comma, infinity. Like that. Yeah. And that would be the proper verbiage to say k is on those intervals. You could also say k is less than negative 4 or k is greater than 0. That works too. That's fine. Okay. Hey, pretty cool. This one took a little longer to explain, but I really wanted to deep dive into the mathematics going on in the background of this one. So anyway, I'm super proud of you for being here. Very happy that you guys are with me for this journey. Can't wait to meet you in the fall and work through more of this stuff. Hope you're having a great time, great summer. Go outside, do something fun. I'll see you in the next video.